Welcome to GCP Online Meetup number 24. I'm one of your hosts, Jonathan Cham, and we have today our lovely
Priyanka Vargaria.
All right, so Priyanka, we are talking about Deployment Manager today with one of our favorite people, Duncan. Are you there, Duncan?
Howdy, how you doing?
All right, so Deployment Manager. What do you know about Deployment Manager?
Nothing.
Oh, okay. Well, I guess we got a lot to learn today. Thank you for everyone chatting in the live chat. We already have some questions, but we're actually going to get started. We'll definitely make sure we answer some of your questions. Duncan, are you ready to wow us with Deployment Manager?
I'm going to try.
Let's do it.
Okay, well, thank you everybody for joining us. This is going to be a fairly high-level treatment of Deployment Manager, but we're going to dig deep in a couple of areas, which hopefully you'll find very interesting. So I'm going to get cracking. So really, the aim of this session is to figure out how you can templatize and automate deployments using GCP Deployment Manager. We're actually going to focus on kind of a real-world use case, just to make this kind of a bit more practical. So we're going to kind of do some theory interspersed with demos that are going to show an example to actually build and configure a GlusterFS cluster. So that should be interesting. We're going to talk about how to troubleshoot dependency management and also some interesting coordination techniques using our Runtime Configurator service. We
really like demos.
Demos are good, and this is going to be live, all right? So I'm not. This is no like video recording. So
yes.
you know, all the usual caveats apply. Okay, so do you guys ever feel like this guy here? I know I do sometimes. Automation is definitely a good thing, and sometimes it can feel like, you know, we're kind of maybe giving the appearance of something being automated, but in fact there's always, or maybe there's too many humans in the loop. So you know, the aim of this talk is to talk about how we can not become this man. So just quickly before I get into the main presentation, there's a really great book which I'm sure a lot of you have heard of and read, called Site Reliability Engineering. It's a really great collection of essays by Google SREs, and one of the chapters within this book actually is talking about this thing, toil, and like toil is like the enemy of the SRE, and it's, you know, it's manual work. It tends to be very repetitive, not much value add, and it could be easily automated with, you know, with some engineering effort. So certainly the goal of SRE is to automate everything as far as possible, and Deployment Manager is a really great tool to help do that. But definitely recommend reading this book. I'll provide a link to it. There is an online version. I will provide a link to that at the end of the talk. So what is a Deployment Manager? So very succinctly, in one sentence, it is an infrastructure deployment service that automates the creation and management of GCP resources. So just note here that it's specific to GCP, so it's not currently going to enable you to automate things that are outside of the GCP portfolio. Additionally, it tends to it works at the platform level. It doesn't go too much into operating system or app layers. There are ways to get around that, but typically its focus is on the GCP portfolio.
So Duncan, I mean, it sounds like with Deployment Manager, that's kind of a positive thing. It's probably all integrated with different GCP technologies, but that seems like it's also a limitation, right?
Yeah, I mean, it's certainly a limitation, but you can overcome it. Typically, what we find is that customers have a kind of a higher level orchestration service, and that can then call down into Deployment Manager. So Deployment Manager is really good at stuff on GCP, but when you need to kind of have a high level orchestration frameworks, and often other people, customers will use something that sits above Deployment Manager and then kind of calls to it when you need to do stuff on GCP.
Does it supplement or complement tools like Chef and Puppet?
Yeah, I mean, they're kind of working at slightly different levels of abstraction. But yes, there are plugins for those tools for Deployment Manager. They do tend to be limited to like the compute side of things, so you don't always get the full scope of the full scope of services. But then typically what people will do will kind of, like I said before, they'll just kind of make a call out to Deployment Manager to allow it to orchestrate all those things. But you can definitely trigger that from those packages. Okay, so just some of the key concepts to think about Deployment Manager. So It is a declarative platform. So what that means is it allows you to say, this is the state of the world that I want on GCP. And then the system itself will make reality look like that state. So pretty powerful syntax. It's a YAML configuration syntax and also a templating engine as well. But it's nice and easy to use. Idea is that you can create these repeatable patterns, repeatable templates that you can then deploy over and over again. And you can also parameterize those templates for reuse as well. So a very, very powerful platform. I'm not going to spend too much time talking through these. I already want to get the demo because it's easier to kind of put handles on the concepts there. So the scenario we're actually going to talk about here is deploying a functioning GlusterFS cluster. At a high level, this kind of shows where this might sit into a full, a full solution. So this is showing like an HPC architecture at a very, very high level. Typically, you have like a big bunch of compute nodes and some kind of shared file system underneath that. So we're going to be looking at that shared file system component. And drilling down a bit more, these are the components that we're going to automate. So we're going to have a number of GCE instances, which will be the Gluster nodes. We're going to do 3 in this example, but it can be as many as you want. We're going to have a persistent disk that attaches to each of these that's going to form the file system. An actual Gluster volume there, GV0. We're actually going to deploy that volume as part of the template as well. So by the time we've actually finished, we have a functioning Gluster cluster, and clients can mount a file system.
That's really cool. So for those of you who don't know GlusterFS, so GlusterFS is just a shared file system technology, and I guess today you would have to use a partner for a shared kind of elastic file system on Google Cloud. Is that correct?
Yeah, so it's one of those file systems out there which handles the kind of the concurrent access case. So equivalents like Gluster is one that was used traditionally, but Gluster seems to be getting very popular as well.
Right.
So this is what we're going to be deploying, and the Gluster side of things is pretty straightforward. Essentially, this is showing a config with 2 nodes. We'll actually have 3 in our examples, but just kind of add another node to it. It's going to create a replicated volume, which means that every block that gets written gets replicated a set number of times to a set number of replicas in the cluster. So it's kind of it's designed for durability as opposed to strict performance. So that's what we're going to be deploying. And the high-level steps, if you were to do this kind of by hand, would look like this. So there are some steps we do on all of the nodes. So that is, we're going to spin up an instance, and we're going to create a persistent disk, and we're going to attach that to the instance. We're going to create a file system on that, and we're also going to install the relevant GlusterFS packages as well. So we do that on every single node. Then we're going to denote one node as the master. That's it's not like a strict master, as in there is no concept of this within Gluster. It's just for our purposes, there are some steps that we only want to do. We only need to do. So those 3 steps there at the bottom on one of the nodes, which we're going to call the master. We're going to probe the other pairs in the cluster just so it's aware of them and it has them in its registry. We're going to create this replicated volume, which spans all 3 of the nodes. And then we're going to start that volume. And at that point, we should be good to go. So some quick concepts before I launch into the demo. So Deployment Manager, this is kind of the fundamental set of things that it's good to know about. So it has a notion of types. So a type is basically a type of resource that could be deployed. So here we show a compute instance type, but really every single GCP service has its own distinct type. You then create kind of instances of this type resources, and you create a configuration that is basically a collection of these resources, and then that forms like a configuration, a declarative configuration. And then when you want to actually go and deploy that configuration, then you have the notion of creating a deployment, and that is really an instantiation of the resources that are specified within that configuration file. So pretty standard stuff, pretty intuitive. Okay, so that takes us to the demo. So for this first iteration, we're going to try probably a little bit of a naive implementation, but let's just see where we can go with this. So I'm going to switch over to my other window. What I'm showing here actually is another cool thing with GCP, which is source repositories. So The materials for this demo I'm going to pull down from a Git repo. This happens to be one that we actually, we're hosting on our own internal source repository service, which is fully integrated into GCP, provides you full, IAM controls over those repositories, and obviously the security and performance that comes with using GCP generally. So I have a repo here which I'm going to use. And I'm going to do this demo from something called Cloud Shell, which, if you haven't heard of it, is a really, really cool feature of our Cloud Console. You access it by clicking here. Essentially, what it does is spin up a shell environment within your browser. So you don't need to kind of install any SDKs. You don't need to get kind of permission to install things. This all works within the context of a browser, and it has all of the SDKs pre-installed, has full access into your project. So I'm just going to get my...
Shell is one of my customers' favorite tools. I mean, every customer kind of touts the awesomeness of Cloud Shell. It's a one-click button. You're in your environment. You got all the security permission set up. You don't need to do anything. You just start, get in and go. Yeah, it's actually really, really cool. You can customize it a fair degree as well. So while it's like the overall environment is ephemeral, you do have a persistent home directory which follows you around. It follows your user around across all the projects that you might be working within. So you can customize things. You can like build source and kind of have it within your home directory and make sure, as long as your path is pointing to your, the bin directory in your home directory, then you can kind of customize it pretty easily. So first of all, I'm going to pull down. So I'm going to look at my history because I've done this before pretty recently. So I'm going to pull this down from the source repo. Using the gcloud command line, it handles all of the authentication piece for you. So that makes it really, really trivial to operate with that source repo. So I'm just going to show you what we have here within this. So first thing I'm going to do is I'm going to show you the kind of the initial, my first stab at this. So I believe that's in here. So this is the first pass. This is a YAML configuration file. I'm going to take you through. The different components of this to make it a little bit easier. I'm going to highlight these, so you can see. At the top level here, we have resources. So like everything we're deploying, everything we're specifying from this point down is going to be a resource, and you can see that we've defined these persistent disk resources here. So we have 3 of them here. We're kind of just going to do it explicitly like this. The type there is compute v1 disk. That says it's a persistent disk, and then each type has its own set of properties that you can define. So for persistent disk, it has a kind of unique set of properties. For example, which zone you want to deploy that into, because persistent disk is a zonal service as a block device. What size is the volume, and also what type, is it standard, is it SSD, and so on. So you can see here that in this kind of naive attempt, I'm actually going to be specifying each of these 3 bricks individually, and I'm going to be kind of spreading them across different zones for. So I'm just going to go ahead there to the next one, perhaps those down. And in the next section, we have a type of compute v1 instance. So we're going to be specifying an instance here. There's a load more properties, as you might imagine, for an instance. So things like zone, what type of machine. I'm just going to put F1 micros to keep costs down. And then you start specifying things like the boot disk. And here we have, this is interesting. So here we have this. This is a reference. So what you can do is you can actually create references to other resources that have been created. And in this case, we want to make sure that the bricks that we created at the top here are going to be attached to this instance. So the way to do that is to pass a reference, which references back to these objects here. The other important thing here to note is the startup script. So for this instance, this is the first instance. This is Gluster 0. So I'm actually going to say, okay, 0 is the master in this case. And so we're going to pull in the packages. We're going to create the file system and so mount the file system. And then we get to the point we talked about before, where we have some special things we just do on the master. So we're gonna probe the peers. We're going to create that volume with 3 replicas and point it to all the other bricks on the other remaining volumes. And then finally, we're going to start the volume. If I was to go forward to one of the other instances, this is Gluster 1 here, you'll see that the startup script is kind of truncated. We don't need that
those other steps because they only need to be done once. So we've just got the file system pieces and that's it. If I want to go and deploy this now, I'm going to show you what that looks like from the command line. So I'll use my tab complete here. One of the great things about using G-Cloud is you can tab complete stuff. So it makes it a lot faster than typing out the full command.
Yeah, I hate
so let's see what
manual to find out, what flags I can use. Using the tab is really cool. Back to the YAML file, is there an easy way to populate all of that information? I mean, there's a lot of stuff in there, right? What's kind of best practices to populate the YAML file?
Yeah, so I'm gonna get to that in the next bit as to how you'd make that bit a bit easier to use.
Yep.
So yeah, I'll get to that shortly.
Okay.
So I'm gonna have to go ahead and deploy this now. So to deploy, just do G-Cloud Deployment Manager deployments because we're operating on deployments, and then you do create, and you give it a name. So I'm gonna call it Gluster-naive, and then need to point it to a configuration file. So we're gonna do this, point it to the YAML file. And if I've got everything correct here, that should go off and do the deployment. I'm going to just move over to the console now, so you can see what this looks like in the GUI. So if I go ahead and this wants to respond, I'm just going to refresh here, and seems to be taking its time a little bit for some reason. Okay, so you can see here, this is the kind of the front portion of the user interface for Deployment Manager. This shows you all the deployments that you have. Oh, this one is finished. It's finished already, which is kind of a little bit suspicious because I know the startup script takes longer to work than that. So we click on there. We can see here the resources that have been deployed. So this here shows you all the resources, and if you click on a resource, there are certain properties for that. You can see the resource properties that we just defined. Going back to the top level, there is a way that you can look at the configuration here. So we just click on here, and we can see all the resources. If I just move that across, move across there. It's not letting me do that. I prefer to use the command line, but it's nice to look at these things in the GUI as well. So that's quickly how you do a deployment. So this is great. This is all very well. I'm just going to go back to the configuration file here. So this is great, but I think there are some obvious problems with this, right? So what if we want to add more nodes to this configuration? So we're going to have to cut and paste the configuration. We're then going to have to go in and tweak things like the names, tweak the zones, tweak these links, and so on. It's not going to be very easy for us to, if we want to turn this into a 10-node cluster instead of a 3-node cluster. It's not going to be very pleasant to do it in the way that we've got this now.
Right. So Duncan, what you're saying is what you just did is not the best way to do it.
Yeah, I would do not do it like that.
Yeah. All right. And why'd you show us?
Well, I just want to get the point home that there are some, there's some great techniques and features that we can use to make this a lot more pleasant. So to the rescue, Ginger.
All right, here we go.
Actually, that's my cat, Ginger.
Oh.
Yeah, what I meant to say was Ginger with J's, which is a templating engine. So besides operating with this YAML configuration file, also built into Deployment Manager is the use of Ginger 2 templating. So what is Ginger exactly? For those that don't know, I'm sure most of you do, but Ginger really is a general purpose templating language, really kind of aligned with Python. So it's great if you're operating on YAML files, work very nicely there. And it's integrated into Deployment Manager very, very nicely as well. So some of the cool things you can do with Ginger 2 is loops and conditions. So I've got a couple of examples here. So we talked about having a number of nodes we wanted to configure. What if we could just put that configuration inside a loop and just say I want to do 10 nodes and loop around? So that's exactly what we can do. This example here, we're setting a variable nodes, which is basically going to be set to an array of numbers essentially in the range of how many nodes that we have, and then we're gonna loop. We're gonna iterate across all of the nodes for n in nodes, and we can repeat everything inside this block, and then we can also use the variable n, in each, to actually customize resource names and things like that. So that's really, really great to repeat things. We can also set conditions. So in this example, if the node is equal to 0, if we're on that master node as we designated it, then do this stuff. Otherwise, we don't do this stuff.
Hey, Duncan, so this is a relevant question. Per the the deployment manager best practices, Python is preferred over Jinja for templating due to flexibility and efficiency. I mean, this seems like maybe like just a what you feel comfortable with, but do you know why maybe that might be the case of Python versus Jinja?
Yeah, I mean, look, Python is definitely more flexible. So yeah, in terms of speed and flexibility, I would say absolutely. You can do more with Python than I'm sure the templates will be slightly faster to use. Personally, I prefer Jinja because it looks more like the configuration that you're actually going to be writing. So you kind of you've got like what looks like YAML, and I'll show you an example of this shortly. What looks like YAML with some additional kind of operators inserted in it. So to me, I like using it because what you're working with looks more like the actual eventual configuration file. So that's just a personal preference. A lot of the examples we have on our site are in Python, and it's certainly a lot more powerful. But for my personal preference was to use Jinja.
Right. And then is there a option? So John had a question here about you had a script in your YAML file. Could you actually use a reference to something of a script type? Meaning, if the script was larger, could you just reference a script rather than have to put it in there?
Oh, absolutely, yeah. So you can point to a cloud storage bucket, so you can actually give it like the location to a script in GTS, and it will run it. It will pull it down from that location, and it will run it as well. The advantage of inlining it here is that we can kind of mess around with it and change it, which I'm going to show you shortly.
Cool. All right, so Duncan, I know you know our timeline. It's 11:23 here on Pacific time, and I know there's a lot of good questions. So let's try to.
Yep. So what I'm going to do now is I'm going to show a slightly more elegant implementation. So I'm going to open it up. This is like version 2. So this is the YAML configuration file. The first thing you'll notice is that, hey, there's not much stuff here. We're just essentially we're just defining some variables, but this is new. We're passing it a path to a Jinja template here. So let's open up that template. Suppose. Okay, actually. Okay, got there eventually. I'm just going to set the file type to YAML so it's a bit clearer to read. Okay, so this is like a Jinja template, and the main things to point out here is that those variables that we actually defined in the YAML file, we're passing through here, and I'm giving them some kind of more nice-looking names here, some just to make them easy to use in the template. So if we skip forward a little bit here, actually not that far, we'll see in the resources section here. This is where we start to use those loops. So in this instance, we're this loop here is configuring the disks, but we're just gonna we just do the configuration once, and then the rest of it we to actually substitute in the correct names. So we're completely kind of automating the creation of those disks, and then the same thing goes there. If we look at the nodes here as well, we're doing the same thing there. We're just going to have the configuration once, but we're going to use 4 loops to loop around and create them. See what else is interesting that I want to talk about. Let's see. So here we use the condition. So this bit here says if we're on node number 0, then we run these parts of the startup script, and it's going to do all of that Gluster stuff in there. So using loops and conditions, now we have a much more much nicer looking configuration file. I am going to show you one cool feature. So I'm going to insert a bug into this. So I'm actually going to delete this line. I'm going to write that out, and then I'm going to attempt to deploy it. And I'm going to show you something really cool. So there is the ability to actually preview deployment before you actually start creating the resources. So I'm going to give this a unique name. I'm going to point it to the configuration file that we just created, we just edited. .yaml, and then I'm going to add this --preview. Now that's what tells it to don't deploy anything yet. Just run see if the syntax is sane and so on. So this goes ahead and does its thing. this usually works a lot quicker. And oh, look, hey, we got an error already. You can see here that it picked up on that syntax error, the ginger layer there. It was expecting to find an N4 there, and it didn't. So using preview is a really, really great way to find errors. I could just go and update this deployment, or sorry, I could go and fix the bug, and then I could go and update the deployment, and then it go and actually go and fix that, and then do the actual deployment. In the interest of time, I'm probably going to skip to the next section.
Yeah, that's really good. I guess, I mean, I know a lot of customers are using Deployment Manager to deploy large environments, and the last thing they want to do is deploy like half the environment and then run into a bug, right? So that's kind of where preview comes in to help alleviate those.
Right. Yeah, and it doesn't catch everything, right? So you'll still be doing lots of iterations, but it catches like syntactical things in the templates. But yeah, it doesn't catch absolutely everything. So you still want to do like testing of the actual deployment, and in a real production scenario, you'd have some kind of pipeline where you actually really do the deployment into some kind of staging area and run your tests there. So that's great, but there could be some problems with that. And if you actually run that last script in practice, in about 50% of the cases, the creation of the Gluster volume is not going to work. It's going to fail. And the reason is because we have a potential race condition. So we've already said that we're going to have one node that actually creates the volume, and it requires that all of the other nodes have completely finished their startup process. So how can we actually tell that those other nodes have finished the startup process, and how do we enforce that dependency? So one potential solution is we might actually have an explicit dependency in the template in Deployment Manager itself. This example here shows that we've configured the master node with this metadata with the depends on statement, which says these are explicit dependencies on the resources with these names. So you could say, okay, Gluster 0 depends on those other nodes. That's not going to work. That's going to fail as well. And the reason is because with GCE, the instance states come into play here. And this shows the different states an instance can be in. When the instance is in state running, then the instance is booting up, or essentially all you know is that they started to boot the OS. If there is a startup script running, the instance could be in this state, but it hasn't necessarily finished the startup process. So you can't rely on instance states, and you can't rely on these deployment manager dependencies to enforce that. One other idea is you could put a sleep statement in the script there. So you see, here's the block that has the conditional bit, and then basically have the master sleep for some arbitrary time until you hope that everything else is done. Again, don't like that. That's hacky. There's gonna be cases when that fails as well. Luckily, we have something that can help here. It's called Runtime Configurator. And what Runtime Configurator is, essentially, if you're familiar with tools like etcd, Zookeeper, and so on, it operates in a similar fashion. So it's an orchestration system that allows you to dynamically configure services. You can send notifications when there are changes to data. You can have things wait on states. And just to put some kind of more concrete concepts around that, essentially what it is you have a config, which is basically a container for a hierarchical list of variables, and that looks very much like a file system path would look like. And then you create these key value pairs in this hierarchy. And then you can do really cool things, like you can create watchers, and they will watch a specific variable and then return when it changes. So you could use that to dynamically signal things throughout your application. The one we're going to be using here is a waiter. So we're going to watch a specific part of this we're going to watch a specific variable, and then we're only going to return when the number of variables in that path reaches a defined number. So this is really good for startup scenarios. You can say, okay, wait until I see 10 variables, i.e. I've had 10 of these nodes succeed.
Is Runtime Configurator a separate tool, or is it kind of underneath Deployment Manager? Yeah,
you'll find it underneath Deployment Manager from a documentation perspective. It does have its own API, so it's a separate API. But yes, it's a related service.
Cool.
So let's put that into action. Let's see what we could do with Runtime Configurator.
So this is the final best practice, what you should do.
Well, this is like version 3. I mean, you could probably go to like iteration 20 if you wanted to.
Version 3. I mean, there's only so many optimizations you can make before it gets a little too much.
Right, exactly. Okay, so let me just set this again so it looks decent.
Just a summary, you're using Jinja, you're using Deployment Manager, you have a Runtime Configurator. What other components are we using here to make all of this happen?
Well, that's essentially it. So
Okay.
yeah, so I'm going to jump to the first part of this and explain how this works. So you'll see we've got the same kind of syntax as before. We set all the variables, but we've got three new variables here. We have this startup configuration. That's just the name of the configuration. That's going to be the container for all those variables that we create. Then we have two separate waiters we're going to use. We're going to use a volume waiter. This is going to be like for the overall creation of GV0. So when is the whole thing actually done? And then we're going to set a brick waiter. This is just going to be waiting for when those individual nodes have finished creating their own local file systems. So we're going to use two waiters in this case. So in the configuration here, we just have this first block here. This is just creating that configuration, that container. If we move to the next one here, we'll see we have the volume waiter. And we're actually defining this within Deployment Manager. And what we're going to do with this is we set a few dependencies just so it's nice that way. What we're going to do is we're going to say this is a waiter. We're going to wait for we're going to deem success as being one variable created under the success path, and we're going to deem failure as one variable created under the failure path. Just moving forwards a bit here. I'm going to show
Runtime Configurator. All you have to do is set it under that property.
That's yes, correct. Yeah.
Okay. Wow.
Now you can. So there's two ways. So in this example, we created the waiter within Deployment Manager itself because we want, for that waiter, we want it to be aware of things happening at the Deployment Manager level. We're also going to use in the startup script. We're going to use a slightly different approach. So let's just run through this because there's a lot of good stuff in here. This is relevant. So this is the startup script that you might recognize from before, but we've modified it pretty significantly. So in this case here, this is the end of when we've actually finished creating the bricks locally. And at this point, we're going to actually create a variable under that brick waiter to say, hey, I've done. So I've actually finished my brick. And then that's all of the non-master nodes, that's all they're doing is just doing this piece and then setting that variable to say that it succeeded. On the master node, first thing we're going to do is we're going to create, using the gcloud command, we're going to create a waiter that essentially waits for all those bricks to finish doing their thing. It's going to wait for a certain number of these variables to be created, which is equal to the number of nodes that we're defining in the cluster. The master is also creating its own variable as well. So this will just sit here and spin until it sees, in this case, 3 of these variables, and then it will proceed. We've got some failure handling logic there. You can actually, if any of this stuff fails, I can then set the higher level waiter, that volume waiter, I can set it to failure. And this will make the deployment fail if something inside this startup script fails. So that's a really nice way of signaling out from the deployment, from the startup script to Deployment Manager itself. So we go ahead, we do these pair probes, we create the volumes. If the Gluster Volume process fails for some reason, then we're going to do the same thing. We're going to mark the whole deployment as failed using this command here. Assuming that everything here works fine, the final thing we're going to do is we're going to create a variable under the success path, and that then signals everything is good. The deployment basically will then have succeeded. So this shows how you can use Runtime Configurator both within the context of Deployment Manager and also from within a startup script too. So I'm going to do we have time to actually go ahead and show this in action?
Yeah, I mean, you might as well do it. You've already gone this far.
Okay, so I'm going to go ahead and I'm going to create a new deployment using the great tab complete. Let me call this one Gluster Demo. I point it to the YAML file we just created. You can also pass the async flag, which means that it returns to you straight away, and you're not tying up your console. So this should hopefully just work. Okay, so you can.
Okay, how do you check the status? I guess is there like a command line option to check status?
Yeah, so you can just describe. You can do a describe operation on the deployment. I actually like the GUI because it's. Let me go back to that's the wrong window. Yeah, I like the GUI because let's see here. That should, yeah.
There you go.
Yeah, so in the GUI, you get to see like these things in a more kind of intuitive fashion. So right here, you can see basically everything here is, in terms of the resources are finished, but this waiter is still spinning. That higher level volume waiter, that's still sitting there and spinning around, because if I was to go to Gluster 0 now, so I'll see that it is still doing its thing. Actually, let's just go to Compute Engine. I can actually show this, because this is another great thing about GCP is you can very easily get access to the serial console. So if I look here at the bottom here, I think it may even, let's see here. Huh. Well, this is, I think I've got some troubleshooting to do in this particular instance, unless someone, this may actually be an instance that was used for a previous deployment, because I didn't see the usual set of messages that I see there. So yeah, ordinarily what would happen is, you would see like, the volume was deployed successfully. What I think may have happened is there's some issue here. We go back to Deployment Manager. What I think will happen is this will sit and spin, and then it'll probably fail at some point. You can set a timeout on this wait as well. Yes.
I guess, being a new user, right, I would love to try Deployment Manager out and see how it works for me. So for that reason, the script that you showed, the Ginger script and everything, is that available, or are you going to make a GitHub repository available after this?
Absolutely, yes. So I'm just showing some of the links here we've talked about. So we have some official Deployment Manager samples, which are probably going to be the way you want to start. And however, I do have the templates that I've just demoed here in this my own repository, my personal repository there at the bottom. So
great.
DJ Rut, GCP Gluster down there at the bottom. I've probably got a couple more bugs to iron out here on this one, but it's pretty solid. It's been working pretty consistently. So there's some new thing has been introduced since I last tested it.
Yeah, if you let us know what went wrong, we can update it on. So I'm planning to have an online meetup GitHub. I'll probably just fork your repo, and then if you find out maybe what happened, then we can figure it out. I mean, it's possible that you fat fingered something, right? That happens a lot.
Well, what I suspect has happened is that I didn't clean up my previous deployments, and they were using the same host names. Mm-hmm. So yeah, what you were seeing there, I think it was failing because there was already an instance with that name. So it would have actually worked if I'd have taken the time to delete all of those previous deployments.
Right. I think Priyanka was going to ask another question.
Yeah, so I wanted to know if there is any plugins to Deployment Manager. Like, can I use Jenkins?
Yeah, there is a Jenkins plugin, yes.
Cool.
Okay.
Yeah, and that's on GitHub. If you, we can actually share the link to that. So yes, there is a plugin for Jenkins. Again, support does tend to be focused around like compute engine. So yeah, very often you need to kind of go down to the deployment manager level if you want to use the full range of GCP services.
Mm-hmm.
Okay.
And okay, yeah, no, I mean, this is really great. Like, thank you so much, Duncan, for doing this. We had one more question from the chat, and it was Jinja versus Python. Like, is there anything in Python that you can't do in Jinja, or vice versa?
I don't.
Personal taste, right? Like how well.
Yeah, I mean, I think when you really get into, I mean, they're different things, right? I mean, Jinja is obviously a templating engine, so like, there's nothing you can't do in Python that you can do with Jinja. It's just that things are going to be a lot easier in terms of there's fewer lines of code to write doing things natively in Jinja, but you don't get the expressiveness and flexibility of Python. And if you're doing like a really, really large, hairy deployment that you want to use Python, because you can start to kind of encapsulate things in, inside of functions and use generators and so on. So
right.
For this purpose, it was ideal.
Yeah, I think I do see. I mean, I think as your environment gets larger, more complex, Jinja does seem to make it a little bit easier to manage. But a lot of people are just familiar with Python and they just want to stick with Python.
Right.
That's sort of what I'm seeing. But yeah, so hopefully that answers your question. Okay, I think that's it. Thank you so much, everyone, for joining. We'll see you next time. We're going to be talking about Stackdriver and how to manage and monitor your applications with Stackdriver. And let us know if you have any questions in the meantime. Thanks, Duncan. Thanks, Priyanka.
Thanks, guys.
Thank you. Bye.
Bye.